Dear students, in today's video, we are going to discuss the limitations of Coulomb law. We will discuss total 5 limitations of the Coulomb law. As per our knowledge, a Coulomb law is used to calculate the force between the charged particles. If you have two positive charges, then they will repel each other and the Coulomb force will be outward. If you have one of the charge positive and another one is negative, the force between them is the attraction force. The force varies as Q1 dot Q2 divided by R square. Right? The first limitation is that it is applicable to static charges only. You can apply Coulomb law only if the charges are not moving. Charges are not moving. They are static. Static means the charges are at rest. Static means the charges are stationary charges. They are not moving. Because when the charges move, due to the movement of charges, current is generated, and that current result in the formation of magnetic field around the charged particle, due to which the force will be not the Coulomb force, the magnetic forces will be there also, right? So if you want to apply Coulomb's law, the must condition is that your charge must be static one. The second limitation is that Coulomb law is applicable to point charges only. If you have 2 point charges, one charge is Q1 and another point charge is Q2, then you can apply Coulomb law to calculate the force between the charges. To understand this concept, let us consider two spheres, the first sphere and the second sphere. Both these spheres are negatively charged. This green dot represents the center of gravity. Center of gravity. Initially, when the spheres are at a certain distance, the center of gravity is exactly at the middle of the sphere. When both the spheres are brought closer to each other, as both have negative charge, they repel each other, due to which the charge appears at this side of the first sphere and at the another side of the second sphere. And you can see that the center of gravity has also shifted from its middle position. So the forces are not balanced. Forces are not balanced in this case. So the Coulomb law can be applied to point charges only. The third limitation is that Coulomb's law cannot be applied if the distance between the charges is very large. Let us see that if you have two charges Q1 and Q2, they are placed at certain distance and the distance is in centimeters. Then you can talk about the Coulomb's law, that it can be applied to calculate the total force between the charges. In the second situation, let us say Q1 is one charge and Q2 is another charge, and this distance is kilometer. Means one charge is with you and another charge is placed certain kilometers away from you. Then you can't implement Coulomb law to calculate the force between these two charges if they are at very large distance. The fourth limitation of the Coulomb's law is that the distance between the charges is very small. Small means it is having the size as that of the nucleus size. We know that inside the nucleus we have several protons and neutrons, right? So the proton both are the charged particles, both have positive charge on them, and the positive charges repel each other. So within the distance of 10⁻⁻15 meter, that is the size of the nucleus, we have mounted positive charges the proton inside it. So, if the Coulomb law is applicable at such a small distances, then the force of repulsion should be there. One of the protons should repel the second proton, and second proton should be repelled out by the third proton. So due to that, this proton-proton's repulsion will result in breakdown of the nucleus, but actually we have never found breakdown of the nucleus. It means that Coulomb's law cannot be applied if the distance is in the range of 10 raised to power minus 15 meter. The fifth limitation is that Coulomb's law cannot be applied if you have irregular shape objects which carry charge, because if you deal with the regular or the smooth shapes, then it is easy to calculate the distance between the thing, but if the structure is irregular, then it is very difficult to find the distance between the two charged particles. So we always prefer that the charge carrying bodies should have a regular shape or a regular pattern. So these are the total 5 limitations of the Coulomb's law. Kindly like, share and subscribe my channel. Thank you.